We're going to look at polynomial multiplication by a monomial. Monomial meaning one group being distributed to a larger group or a larger polynomial. So when we multiply, well, when we simplify, when we combine terms, I don't like parentheses. I want to do my best to get rid of those parentheses. So we distribute. Now, when I do this, I'm going to take this 5x squared. I'm going to take the negative 4x squared. And we're going to kind of do it in like two different parts. First, I'm going to say 5 and negative 4, giving us negative 20. Then I'm going to say x squared and x squared. Now, if you remember when we're dealing with exponents, if you have the same base, we have to add the exponents. So we're going to say 2 plus 2 is going to give us 4. Now we're going to do it again. 5x squared to that 2x. Two parts, the numbers. 5 times 2 gives us 10. And then we're going to say x squared and x. Now that has an exponent of 1, so add the two exponents. 2 plus 1 gives us 3x to the third power. And one more time, multiply your numbers together. So this time it's going to be 5 and negative 7, giving us negative 35. And there's no x values over here, but that's fine. All I'm going to do is take that x squared in the front and just carry it over to this group. And we just need to make sure that our problem, or well, rather our answer, is in standard form, meaning highest exponent to lowest exponent. We have it. Good. Let's move on. Sometimes you can have more than one parenthesis within a problem, and that's fine. We're just going to take it and we're going to chunk it into little pieces. First group that I'm looking at, 3 times y, giving us 3y. Then we're going to say 3 and negative 2, negative 6. I'm not going to distribute to the 2y because it's not in that same group. It's just separate. So we just bring it right down. Now we have a second set of parentheses with just that 2 on the outside. Do it again. 2 and 2y gives us 4y. 2 and 7 gives us 14. Okay, so we distributed, we got rid of the parentheses. Now we're left with this big, massive list of terms. Let's combine like pieces together. Combine your like terms. I want to put together, in this case, my 3y, my 2y, and my 4y. I circled everything that had a y, but notice I also circled the sign that came along with it. That's going to be important too. 3 doesn't have one, but if it doesn't have a sign, that means it's going to be positive. So 4 plus 2 is 6. 6 plus 3 is going to be 9. 9 what? We're talking about y's. All we have left is negative 6 and 14. What's 14 minus 6? It's going to give us 8 in the positive. I'm going to call it a day. So we didn't have an equal sign there, and all we were doing was kind of just cleaning up our problem. We had a big mess. We're going to kind of straighten it out and then put it together. We now have an equal sign, and notice when we have an equal sign, and now directions now say solve. I need to figure out what is y. Okay? Basically, what we just did over here is what we're going to do to this problem, and they look very similar, so we kind of have half the problem already done. So we know when we distribute, you're going to get 3y minus 6, bring the 2y down. And what I like to do is kind of like simplify one side first. Let's put these two together. 3 and 2, because they're like terms, is going to give us 5y. 6 doesn't do anything. We can then worry about the right side, distribute. 4y and 14. So again, what we just did over there, but we got that equal sign in the middle. So let's just bring it all down so everything's level. Now you're left with a two-step, multi-step equation here. Let's get y's all to one side. I want to take this 4y and move it over. I want to get my y's in the front. So I subtract, that's gone. I'm left with 1y minus 6 and 14. Do I need that 1 there? No. If you have a 1 in front of a variable, you can just get rid of it. Move the 6 by adding y equals 20. And yeah, that is polynomial multiplication using monomials.